Alright, here's a fun problem. Lesson 117, number 10. So I think I did a lecture video on this, region of interest. So what you do is the polynomial has to be normalized, or in other words, the lead coefficient has to be 1, and it is. So it's already normalized. Then you go and you look at all the coefficients and you say, well, what's the biggest one of absolute value? Well, 3. We got this constant and we've got that. So absolute value 3 is 3. You add 1 to it. That's the thing about region of interest. You always have to add 1 to it. And I got 4. So that tells me that within this radius of 4, that's all the interesting things are going to happen. Like all the intercepts, the x and y intercepts, and all the turning points are all going to happen here. So when I plot points, if I want to start looking at points, I'm not going to have to pick anything outside of this region of interest. Or in other words, I don't have to pick any big numbers. I already know what the shape of a cubic looks like. I know you guys feel shaky on this, but cubic is the one that looks like a squiggly snake. Okay, it can be like that. Maybe it could be super curvy like that. Might have 2 turning points. It's going to be going upward to the right and downward to the left because it's an odd function and it doesn't have it's positive right here. Okay, so I think I can see where the y-intercept is already just by looking at it. What would happen if I plugged in 0 for x? Well, I can easily see then 3 would be y. So there's a point, and then I can find the x-intercepts. If I just want to real quick do me a little synthetic division on here, that would probably help. Otherwise I just plot points, but synthetic division only takes a minute. Let's just guess. We'll guess and see if maybe 1 is going to go into it. So the coefficient, this is going to be 1, that coefficient's -3, -1, 3. 1 times 1 is 1. 1 times -2, -2. Oh, see, that was easy, wasn't it? Okay, so that's synthetic division. So what that means is that x minus 1 comes from the divisor, and then this is x squared minus 2x plus 3. Oh, sorry, minus 3. Now maybe I can do a diamond problem on it. Wouldn't that be convenient if I could? 3 times 1. So if it was -3 and +1. So this can be written as x minus 1, x minus 3. See, all this factoring is helpful. So I'm going to have zeros at x equals 1, x equals 3, x equals -1. So 1, 3, and -1. So that already pretty much gives away the shape because I know it's probably going to look like this. So it's going to be going up. Then, you know, somehow it's going to turn around before this down here because my region of interest says it will. I'm not sure exactly where. Maybe I'll do that part lightly. Then it's going to come here. It's going to cross through here. It's got to turn back down. So basically that's already a pretty decent sketch. If I want to get picky, like I don't really know for sure, maybe it goes just really shallow right here. We know it doesn't go past 4. But if you really want to know, you just take a second and go, well, let's plug in 2. See what happens. So 2 squared is 8. 2 cubed is 8. 2 squared is 4 times 3 is 12. What's that? 14. 3. I'm getting 3. No, I'm getting -3. I don't know. I did some funky math and got -3. So even if I would have just faked it like I was going to, look how close I would have gotten. So that's nice to know. the region of interest helps you a little bit, and it only takes like 1 second to find the region of interest. You just look at it and go, oh, what's the biggest number I see here? And then you take its absolute value, add 1 to it. It's kind of save you some time and some wondering, right? So there it is. Is that all? Let's make sure I answered everything they asked me. They said, use my knowledge of the basic shape. Yes, I did. Use coordinates of the points. Well, yeah, we used our region of interest. Yeah, we're all good.